see a simple soap bubble floating by and you just get lost in it for a second? It shimmers with this incredible moving rainbow of colors. But have you ever actually stopped to ask yourself, why? Where in the world do those colors come from? Well, the answer is hiding in plain sight. And trust me, it's way cooler than you think. So let's solve this mystery together.
And that really is the central question here, isn't it? How can something that's basically just clear, soapy water suddenly burst into this entire spectrum of color? I mean, when you think about it, it just doesn't seem to add up.
Okay, so where do they come from? Your brain is probably jumping to conclusions, right? Maybe there's some dye in the soap, or it's just reflecting something colorful nearby. Nope. The real answer is so much more interesting, and it has everything to do with the nature of light itself. And this is the part that really makes your head spin. A bubble isn't like a painted ball or a colorful piece of clothing. It's transparent. It has no color of its own. So the color isn't in the bubble. The color is being created by the bubble. And figuring out how, well, that's the key to everything. All right, to crack this case, we've got to look at two main suspects, or clues, if you like. The first one is the bubble itself, and the second one is light. Let's start with the bubble. So first up, what even is a bubble? Well, physicists have a name for it, a thin film. And look, when I say thin, I mean crazy thin. We are talking thousands of times thinner than a single strand of your hair. It's basically a water sandwich with soap as the bread. And you really need to lock this idea away, because this little detail, the fact that it's so incredibly thin, it's not just some fun fact. It is the absolute key to this entire phenomenon. This is the stage where all the action takes place. Okay, on to clue number 2, light. You know, sunlight looks white or kind of yellow, right? Well, that's basically an illusion. White light isn't a single color. It's a jumble of all the colors of the rainbow, all mixed together and traveling as one. Think about how a prism works. It doesn't create the colors, it just separates the ones that were already there. All right, so we've got our two key ingredients. We've got an impossibly thin film of soapy water, and we've got light that's secretly carrying every color imaginable. Now, let's smash them together. This is where the real magic happens. So let's follow a little particle of light on its journey. When that light hits the bubble, it splits. Part of it bounces right off the outer surface, but the rest of it actually goes through that super thin soapy wall and then bounces off the inner surface. So now you've got these two light waves bouncing back towards your eyes, and they're on a collision course. Now, this collision has a name. It's called interference. And it's what happens anytime waves run into each other, whether they're in water or, in this case, light waves. And think of it this way. They can either team up and get stronger, or they can fight and cancel each other out. And there are really only two things that can happen here. In one scenario, the two reflected waves line up perfectly. They reinforce each other, making that one specific color super bright and vibrant for you to see. But in the other scenario, the waves are out of sync. They completely cancel each other out, and poof, that color is just gone, erased from existence. Okay, so that explains how we can see one color. But wait a second, a bubble isn't just one solid color, is it? No way. It's a constantly shifting, swirling, dancing rainbow. So what's causing that? Which brings us to the next big question, right? If the physics is that straightforward, why isn't a bubble just a solid, single-colored sphere? Why is it always swirling and changing? Well, the thing is, a bubble is never standing still. It's a living, breathing thing. Gravity is always pulling the water down, making the top of the bubble thinner and the bottom thicker. The air is swirling around it. The thickness of that soapy wall is constantly changing, everywhere, all at once. And this is the money shot. This is the whole secret right here. It all comes down to this one simple, beautiful rule. Different thickness equals different colors. A spot that's just a tiny bit thicker might perfectly amplify the color red. A spot right next to it, just a fraction thinner, might be perfect for amplifying green. So as the bubble's wall shifts and flows, the colors you see dance right along with it. So have you ever noticed this? Just before a bubble pops, you sometimes see these dark, kind of black spots show up on it. What's going on there? Is it getting dirty? Well, this brings us right back to that idea of interference. Those black spots are areas where the bubble's wall has gotten so dangerously thin that it causes every color of light to cancel itself out. So absolutely no color is reflected back to your eye. And what do we see when there's no light? Black. It's basically the bubble's last warning. You know, the coolest part about figuring this out is that once you see it, you start seeing it everywhere. This isn't some weird thing that only happens with bubbles. This exact same science is happening all around you, all the time. You know that rainbow shimmer on an oil slick in a puddle? Yup, same exact science. Or that rainbow of colors you see on a wet road at night under the streetlights? You guessed it. It's all about a thin film playing tricks with light. Which, of course, brings us to the sad but inevitable end of every bubble. That thinning process we talked about, the one where gravity pulls the water down, does it ever stop? Not a chance. It just gets thinner and thinner and thinner, and those black spots start to spread as the wall gets stretched to its absolute limit. And eventually, it becomes too fragile to hold itself together. The surface tension gives way, and then pop! So there you have it. The mystery is solved. And it's a beautiful 4-step process. You start with a thin film, you shine light on it, which contains all the colors. The light waves bounce and interfere with each other, and the thickness of that film at any given spot determines the exact color you see. It's so simple, but at the same time, it's absolutely brilliant. And really, that's what I want you to take away from this. A bubble isn't just a toy. It's a gorgeous, floating, and very temporary science experiment. You're literally watching wave mechanics happen right in front of you. This is the best kind of science, the kind that's hidden in all the things we see every day. So that makes me wonder, what other everyday mysteries should we tackle next? What's something you've always wondered about? Drop your ideas in the comments. We might just break it down in our next explainer. Thanks for hanging out with me for this one.